Some dinosaurs, while not the most beloved and revered animals of the Mesozoic, have been shaped and molded by popular culture to the point where they are no longer the organisms they once were. There is no greater example of this than the dinosaur today's video centers around, Dilophosaurus, a medium-sized theropod dinosaur from the early Jurassic of North America. It is very likely that you will recognize the fictional depiction of Dilophosaurus from the Jurassic Park and Jurassic World film franchises. Dilophosaurus is the dinosaur that in the film is shown to spit venom at its prey in the form of corrosive spit globules that are launched out of a brightly colored frill adorning the flank of its head. This representation has had a knock-on effect, and it is common to see Dilophosaurus depicted in this way in models, toys, and even video games, some of which aren't even directly related to the Jurassic Park franchise. In reality, there is no evidence for such features, and today we will be exploring the real facts and figures behind this incredible dinosaur. Sit back and relax as we take you back to the early Jurassic to discover Dilophosaurus, the most misinterpreted dinosaur of all time. Let's start by discussing what we're up against. The notion that Dilophosaurus was a dinosaur with an extendable neck frill that could spit venom. This dinosaur has become one of the unsung heroes of the Jurassic Park and Jurassic World film franchises, a fan favorite that extends beyond the iconic Tyrannosaurus and Velociraptors depicted throughout the series. This is almost certainly due to the dinosaur's outlandish appearance and abilities, namely the extendable frill and venom glands that can launch corrosive liquid venom into the faces of their prey. Moreover, the dinosaurs in the films are shown to be able to rattle their frills like the tails of some snakes, creating a vibration effect that would presumably serve to intimidate their opponent further. The explanation for these traits in the movies is that scientists at Jurassic Park spliced the DNA of Dilophosaurus with the DNA of poisonous frogs, which resulted in abnormalities and errors in the cloned dinosaurs. Throughout the franchise, Dilophosaurus is portrayed as a purely violent, antagonistic monster of a dinosaur, earning itself a starring role in the iconic scene in the first Jurassic Park movie, when the character Dennis Nedry is shown to be killed by the animal. Dilophosaurus is shown to repeatedly spray venom into the eyes of the poor character, who suffers a terrible fate at the hands of this ravenous monster, who proceeds to devour him. As we mentioned briefly in the introduction to this video, this depiction of Dilophosaurus has had a knock-on effect. In reality, there is no evidence at all for frills or venom glands in this dinosaur. They were carnivores, yes, but like all carnivores, these were not merciless killing machines with truly evil natures. A quick Google search will reveal the true extent of this reconstruction's impact on the general public's perception of this dinosaur, with more images showing frills and venom than those that don't. Depictions of this dinosaur portrayed in this way have led to the general public assuming that this was the norm for Dilophosaurus, and a Google search will also reveal several reconstructions of this dinosaur in public areas or theme parks, all of which boast colorful frills. These aren't the only reconstructions of Dilophosaurus in this manner. Surprisingly, the dinosaur canonically exists in the Dungeons & Dragons universe, where it is also portrayed with the neck frill and venom-spitting capabilities. As we're about to find out, the real Dilophosaurus was much different to these media representations. In reality, Dilophosaurus was one of the first medium to large-sized predatory dinosaurs of the Mesozoic, cementing itself in the fossil record towards the beginning of the Jurassic period, around 183 million years ago. The largest known specimen of Dilophosaurus measured around 7 meters in length from nose to tail, with smaller specimens measuring just over 6 meters in length. This is oddly enough much larger than the dinosaurs in Jurassic Park. Typically, exaggerations tend to go the other way. While this might pale in comparison to the giants of the later Jurassic and eventual Cretaceous periods, Dilophosaurus was still the largest known terrestrial animal of North America during this time, despite its agile, slender build. The head of the animal was large in comparison to the rest of its body, but its skull was delicate and lightly built. A series of knife-like teeth were embedded into the jaws of the skull, betraying the nature of a strict carnivore. The most striking feature of the skull, and in extent the most striking feature of the entire dinosaur, is the presence of 2 bony crests on the animal's forehead. These crests were arched, running adjacent to one another from the snout to roughly just above the eye. They grew taller the further back they grew, beginning as short ridges on the snout. These crests were formed by the nasal and lacrimal bones being fused together by bone tissue, and were one of the most striking and identifiable features of this dinosaur. The postcranial skeleton of this dinosaur consisted of a long, tapering vertebrae, ending in a long tail that projected out in a slender fashion from the end of the torso. 2 long hind limbs held the dinosaur aloft, giving it the signature bipedal theropod gait, while 2 much shorter, grasping forelimbs made up the arms and hands of this dinosaur. Dilophosaurus did not possess a very powerful bite, and the overall skull was fragile in comparison to the later theropods. Early interpretations of this dinosaur's feeding habits determined that it was either a scavenger, plucking meat from animals that had already been hunted, or that it used its arms and legs to bring down prey, kicking and slashing with sharp claws. Later, Robert T. Bacher, a famed American paleontologist, rejected this initial theory, stating that Dilophosaurus's elongated neck and large sharp teeth would have been more than enough to allow it to hunt for itself. Further studies proved that the snout was more effectively braced for impact than it was initially thought, and that the animal was not a scavenger. At this point, it was suggested that Dilophosaurus was able to hunt animals as large as prosauropods, the predecessors to the mighty long-necked sauropods that would walk the land later on in the Jurassic. Dilophosaurus' skull also featured an upturned chin that allowed it to grab, lock onto, and eventually manipulate the prey inside its mouth. While the skull was fragile, the bite was powerful, and its jaws were almost certainly used when securing and bringing down prey items. It is thought that Dilophosaurus used its jaws like a set of knives, slashing and cutting at its prey before it was eventually brought down. Later, it was determined that this would have been an ineffective method of bringing down larger prey, and Dilophosaurus likely hunted smaller animals, small herbivorous dinosaurs and other reptiles perhaps. Not only that, but it may have been piscivorous. The tips of the jaws expanded out at the flanks, allowing the teeth to interlock. Similar structures have been seen in dinosaurs that we know for a fact ate fish, such as the Spinosaurids. So there is reason to believe that Dilophosaurus may have stalked by the water's edge like a heron, snatching fish from the water with its large knife-like teeth. Everything changed again in 2018, however, when fossils of the sauropodomorph dinosaur Ceratosaurus were excavated from northeast Arizona, USA. The bones of this dinosaur were dented by tooth impressions that were caused by a carnivorous dinosaur. The only culprit for tooth marks this large was Dilophosaurus. However, scientists thought they had proved that the dinosaur wasn't capable of taking prey as large as a prosauropod. So how could this be explained? Paleontologists Marsh and Rowe published in 2020 that while Dilophosaurus likely fed on fish and small animals, the articulation between different sections of the skull that housed the teeth allowed much more movement than once thought. The jaw therefore was more robust and could deliver more deadly bites to larger animals. Paleontologist Matthew A. Brown determined in 2021 that this evidence meant that Dilophosaurus could indeed puncture bone, and that the dinosaur was not a scavenger. Instead, it was one of the very first apex predator dinosaurs with no natural enemies and a killer bite to accompany its swift, lightweight build. How about the crests then? The first theories on these bizarre structures discussed the idea that they were thermoregulation devices, which allowed the dinosaur to filter heat to control their own temperatures. Moreover, he predicted that Dilophosaurus used these crests to recognize each other as a species, and they were likely colored in vibrant, striking patterns to help the dinosaurs distinguish each other. The crests were plainly not weapons. They were too delicate to have been used like horns or blunt domes seen in other animals. Later theories have homed in on the idea that the crests were used as display features, used to help female Dilophosauruses choose a mate amongst displaying males. The crests were likely colored in striking hues that differed from the rest of the body color, allowing them to stand out amidst the environment to create the most vibrant display possible. Meanwhile, the species recognition idea has plummeted into obscurity, as no modern animals use body parts in this way. As for the venom, this is entirely a work of fiction. While it has captured the imagination of filmmakers and film fans alike, the notion of a dinosaur spitting venom, or even being venomous, is a false one. There is no evidence at all for frills in this dinosaur, nor is there any evidence of venom glands anywhere in the skull. Dilophosaurus' story in the Age of Man can be traced back to 1942, when Charles L. Camp, a paleontologist working for the University of California's Museum of Paleontology, led an expedition to the rocks of Arizona's Navajo County, the Kayenta Formation. They worked side by side with local native Navajo people, where they found 3 dinosaur skeletons in the shale rocks lining the outcrops of the vast open wilderness. These skeletons were arranged close to each other, and the first of them was almost complete. The second was heavily eroded, and the third was eroded to the point where it was almost unrecognizable. The greatest attention was therefore paid to the first dinosaur, which was extracted from the ground and coated in plaster, where it was sent to the museum. Paleontologist Juan Langston was the first to study these dinosaurs, most closely the first one, which was encased in rock in a classic death pose, with its neck and tail splayed back across its vertebrae. Samuel P. Wells, who later studied the dinosaur, placed it initially in the genus Megalosaurus, naming it Megalosaurus weatherili, honoring John Wetherill, a Navajo counselor who assisted in the excavation. Upon undertaking further studies, Wells determined that this dinosaur was too different to Megalosaurus to place it in the same genus. Rather, Wells decided to name the dinosaur Dilophosaurus weatherali, meaning two-crested lizard in English, on account of its striking skull crests. Later in 2001, 3 more Dilophosaurus specimens were unearthed, identified by Robert J. Gay. These fossils had already been unearthed years ago and were sitting in the collections of the Museum of Northern Arizona. These specimens contained elements that were missing from the initial trio of dinosaurs, including a complete pelvis and parts of the ribcage. There was also a young animal present, one of the earliest known juvenile dinosaurs discovered from North America, which has given scientists a valuable insight into the growth rates and differences between young and adult specimens of this dinosaur. Venomous dinosaurs might seem like a complete work of fiction, but you might be surprised that one species has already been investigated regarding its possible venomous bite. Sinornithosaurus, a little dromaeosaur discovered in 1999 from the early Cretaceous of China, is the only dinosaur that may have delivered a lethal venomous bite to its prey that we know of. One Sinornithosaurus skull examined by Embu Gong and his team prompted them to take particular note of the strikingly different upper maxillary teeth, which were much longer and curved than teeth found in this location in other related dinosaurs. Not only were these teeth longer, they were also grooved down the outer surface, which is a feature seen in many venomous animals in the modern day. A tiny cavity just above these teeth, which was not present on any other teeth, may have been evidence of a possible venom gland, where a toxic substance would have been pumped into the tooth for injection via the fangs. The team proposed that this was a venomous dinosaur that hunted small prey items, paralyzing them with potent venom in the same manner a snake might do today. Later in 2010, Federico Giancini challenged this idea with a newly published paper. Federico and his team took note of several other dinosaurs that also possess similar grooves on the teeth to the ones found in Sinornithosaurus. They also noted that the teeth were initially described as being much longer than normal and were simply just teeth that had been removed from their sockets throughout the fossilization period, making them look much longer than they really were. They also could not find sufficient evidence that venom glands were present above the teeth and were only able to find openings, glands, and sinuses found in every other dromaeosaur. So was this wishful thinking on Gong's part, or was he right? Gong responded in the same journal with more of his findings. He commented on the fact that many theropods did indeed have grooved teeth, but suggested the idea that venom might have been a primitive trait seen in archosaurs, which was retained by dinosaurs similar to Sinornithosaurus. Gong argued that the teeth had not been displaced from their sockets, but did acknowledge the fact that they had been obscured slightly throughout fossilization. He ended his report by stating that Sinornithosaurus may not have been venomous if we only take into consideration the grooves of the teeth, as many non-venomous animals in the modern era, such as baboons, possess grooves on their teeth to help them eat a variety of foods. The jury is still out, but the evidence is pointing to the fact that it is unlikely dinosaurs were capable of producing and weaponizing venom to subdue their prey. It is at this stage a fanciful idea, one that has not been proven with any concrete evidence, but who knows how this might change in the future. Paleontological debates are lengthy and ongoing, and more evidence may be uncovered going forward. Dilophosaurus, however, can be confidently placed in the non-venomous category for now. Dilophosaurus's home was the Kayenta Formation of ancient Arizona, a rock formation known for siltstone in the midst of the Glen Canyon Group. In life, the formation was mostly riverine, with networks of fresh water cutting through the land. While lush conifer forests occupied much of the region, it was seasonally dry, and sand dunes occasionally permeated the environment over the drier parts of the year. Dilophosaurus is known to have shared its home with many other dinosaur species. The Kayenta Formation is known for the likes of Megapnosaurus and Kayenta venador, two smaller species of theropod. Scutellosaurus is perhaps the most famous non-Dilophosaurus dinosaur of the region, an early thyreophorine that may have been the ancestor of some of the heavy armored ankylosaurs that appeared later on in the Jurassic. Small mammals, in fact some of the earliest true mammals, sprinted through the forest, whilst fish and amphibians schooled and bred in the slow-running rivers below. For much of the year, it was a lush green world teeming with life. While Dilophosaurus may not be one of the most instantly recognizable dinosaurs, it remains one that has had a major cultural impact on the paleomedia it has inspired. While the world might know Dilophosaurus as a frilled, spitting predator, the reality was much more nuanced and complex. And this was in fact one of the first large dinosaurs to break through to apex predator status in the early forests of North America. It was this early predator that through trial and error paved the way for the later giants of the Jurassic, and it didn't need corrosive venom or extravagant neck frills to do it.